Make sure you have your name, date, and period in the top right-hand corner. The title of this note is Polynomial Sketching. And your goal is to be able to analyze the features of a polynomial function from just its equation so that you can produce a sketch of what its graph should look like without actually using a calculator. So the first thing we're going to look at, and there are a lot of parts. I'm going to jump down to the end here. Every time you do a problem, and here's an example of a polynomial, what does its graph look like? This list of questions is what you're going to answer to produce a sketch. So in the notes, I'm going to take you through how you answer each of these questions, and then at the end, we're going to sketch this one together. So the first thing we need to talk about is the end behavior. Does the graph go up or down towards the right or the left? So the first thing you're going to look at is the degree. The degree is the largest exponent, and then the leading coefficient is the coefficient of that term. This is the same vocabulary you practiced when you were looking at quadratic functions in Algebra 1 and Algebra 2. So what you want to look at is your leading coefficient. I've abbreviated that LC in my notes. If your leading coefficient is positive, that means that your graph is going up to the right. If your leading coefficient is negative, that means that your graph is going down to the right. So your leading coefficient tells you what's happening on the right. Make sure you spell that word correctly. And then to figure out what's happening on the left, you're going to look at the degree. If you have an even degree, your right and your left match. So they're both up or both down. If you have an odd degree, your right and your left differ, one up, one down. So quick example, if you have y equals negative 2x cubed. First, I'm going to look at my leading coefficient. It's negative, so that tells me the graph is going down to the right. And then the degree is that exponent 3. So that tells me that the left and the right have different behaviors. So because it's going down to the right, it has to do the opposite. So it's going to go up to the left. We don't know anything yet about what's going on in the middle, but we can tell about what's going on the ends. That's why it's called the end behavior. All right, so the next thing we're going to talk about is turns. How many times does the graph turn? So a turn is like, oh, it's going up, down, up. This quick sketch turns once, twice. So there's something called the fundamental theorem of algebra, which was first proven by our man Gauss, the guy who brought you matrices. And we find that a polynomial of n degree, so n is the degree, that highest exponent, is going to have n roots. So your roots are your solutions, or your zeros, or your x-intercepts. All four of those words kind of mean the same thing. And then from the fundamental theorem of algebra, mathematicians have figured out that if you have a polynomial of n degree, it has at most n minus 1 turns. It could have fewer, but that is at most. So for example, if I have y equals x to the 4th power, my degree is 4. That's this n that is coming up in this fundamental theorem of algebra. So it has 4 solutions, or roots, or zeros, or x-intercepts. And then it has 1 fewer turns. So it has 3 turns as a maximum. So what that could look like, it could be going up, down, again. So it could have 1, 2, 3 turns. It could have fewer turns. There's a way for it to have 2 turns or actually 1 turn. If we were to graph this, this one does actually only have 1 turn. The graph of y equals x to the 4th power looks like a really flat parabola. So unfortunately, Gauss didn't figure out how to tell us how many turns it has. All we know is the maximum number of turns. We know this has a maximum number of turns of 3. We don't quite know yet how to tell if it has 3, 2, or 1 turns. All right, so after we have talked about how many turns it might have, we're going to talk about where could the zeros be. And I'm going to flip back for a second. Remember, the zeros is another word for the roots. And Gauss proved to us by the fundamental theorem of algebra that if it's an n degree, it has n roots. So this y equals x to the 4th has 4 roots. It has 4 solutions. So where are they? Well, we're not exactly sure where they are, but we're going to use something called the rational zero theorem to come up with a list of possible zeros. And the way you come up with a list of possible zeros is you're going to take all the factors of the constant term. Remember, that's your term with no variable. And then you're going to divide it, that's what this fraction bar is doing here. This is division, by all the factors of the leading coefficient. And you're going to come up with a big list of possibilities. So just as a quick example, let's suppose you have y equals 2x squared minus x plus 6. And I wanted to say, hey, where are the solutions? Where are the zeros? Right now, we can come up with just a list of some possibilities. So the constant term here is 6. What are the factors of 6? They are 6 and 1, 3 and 2. 6 times 1 is 6, 3 times 2 is 6. And then we're also going to look at our leading coefficient, which is 2. And the factors of 2 are 1 and 2. So to make our list, we're going to take all of the factors of the constant term. So we have 1, 2, 3, and 6. And we're going to divide them by all the factors of the leading coefficient. So that's 1 and 2. So I'm going to divide 1 by 1. I'm also going to divide it by 2. Because I have to take each number in my red list and divide it by 1 and 2. So 2 divided by 1 and 2 divided by 2. 3 divided by 1 and 3 divided by 2. 6 divided by 1 and 6 divided by 2. Each one of these is a separate number in a list, so those are commas in green. And then I want to simplify wherever possible. I might have some repeats on my list. That's not important. We are only going to list each number once. So here I have the number 1. I also have the number 1/2. 2 divided by 1 gives me the number 2. 2 divided by 2 right here gives me 1, already on my list. I don't need to repeat it. 3 divided by 1 gives me the number 3. I also have the number 3/2. I also have the number 6 divided by 1, 6. And then lastly, 6 divided by 2, that's 3, but that's already on my list. So this here is a list of possible zeros. So my graph of y equals 2x squared minus x plus 6 goes through the x-axis at one of these points. Not all of them, but one of these could be a 0. So then how do you actually figure out which one of those is a 0? So that's when you're going to use factoring. And it is going to involve some guess and checking, but luckily we have a list to work with. You're going to use your list of possible zeros that we just came up with. And the fastest way to guess and check them is to use synthetic division. You practice this in Algebra 2. That's your drop, multiply, add, until you find a 0. Once you've found a 0, you're just going to continue to factor your answer until you have completely factored your polynomial. We will spend more time practicing this in class. Once you have completely factored your polynomial, you will use your factors to find your zeros. You'll set each factor equal to 0, solve, and then that's going to tell you your x-intercepts. Once you have all that information, you're ready to sketch. Make sure that you always label and scale your axes. You will lose points for forgetting to do that. Next, you're going to want to plot your x and y intercepts. And then you want to plot at least one point in each interval. That's in between each x-intercept. And then once you have a few points, then you're going to be ready to sketch your curve. Okay, so we have an example here. Y equals 2x to the 4th power plus 3x cubed minus 12x squared minus 7x plus 6. This is a function, so it should say f of x equals in front of it. Okay, so we're going to use this chart to help us analyze this function. So firstly, what is its degree? That degree is the largest exponent. It's 4. We're not going to ask if it's an even or odd function. It means something very particular. But is the degree even or odd? It's even. Why do I care? It's going to tell me about the ends. What about the leading coefficient? It's positive. Positive 2. What does the leading coefficient tell me? It tells me that this thing goes up to the right. And then the fact that it's an even degree tells me that the left and right match. So on the left, it'll also go up. Up on the left. Okay, the proper notation for this is called a limit. As x goes to infinity. That means you're going to the right on your number line. As x gets really, really large, my function, the outputs, are going up to positive infinity. If they were going down, I would write negative infinity there. And then on the left, that's another limit, as x approaches negative infinity, because I'm going to the left, my function is going to get closer and closer to positive infinity. We'll practice that notation more. This is called limit notation. All right, maximum number of turns. What did Gauss say? Gauss said, take your degree, decrease it by 1. So a 4th degree polynomial has a maximum of 3 turns. All right, all the possible rational zeros. I'm going to take all the factors of 6 and divide it by all the factors of 2. So factors of 6 are 1, 2, 3, 6. Factors of 2 are 1 and 2. So I have 6 over 1, 6 over 2, 3 over 1, 3 over 2, 2 over 1, 2 over 2, and 1 over 1 and 1 over 2. And I'm going to simplify those. 6 divided by 1 is 6. 6 divided by 2 is 3. 3 divided by 1 is also 3. 3 over 2. 2 divided by 1 is 2. 2 divided by 2 is 1. 1 divided by 1 is also 1. And then 1/2. I do need to consider both the positive and the negative. So I'm just going to go put a plus or minus sign in front of each of those. So this is my list of possible zeros. All right, next I want to factor it. This next step is what takes the most work. I'm going to take a number off of my list of possibilities, and I'm going to use synthetic division to see if it's a 0. So this is a little refresher from your Algebra 2 class. So my original function, I'm going to write out just the coefficients. So I have 2, 3, negative 12, see that minus sign? Negative 7, and 6. And let's guess, hey, maybe positive 6 is one of my zeros. This is where I'm going to do that drop, multiply, add pattern. First I'm going to drop the 2, and then I'm going to multiply the 2 and the 6, and then add these together. And then I'm going to multiply the 15 and the 6, and that is 90. And then add, so what is this? 78, right? And then times 6, ooh, these numbers are getting large. Okay, so I have 78 times 6 is 468, minus 7 is 461, times 6, it doesn't even matter, it's a really big number, okay, plus 6, it's not 0. Okay, remember this is a list of possible zeros. It's called a 0 because I'm looking to get a 0 here. So 6 is not a possible, 6 is not actually a 0, even though it's on my list of possibilities. That's okay. I still have this entire rest of this list. Let's pick something else off of the list to try. Let's try a smaller number. That 6 got pretty large pretty fast. Let's try positive. No, let's not do positive. Let's do a negative number. Let's do negative 1. So again, write out the coefficients. Okay, and there's really no way around this. It's going to be tedious. There's guessing and checking. Good thing that we have that list of possibilities. So we're not just pulling arbitrary numbers. All right, so let's try, what did I say we were going to try? -1? Let's do -1. All right, drop your 2. Multiply. 2 times -1. Add. Multiply. Add. Multiply. 13 minus 7 is 6, right? And then 6 times -1 is -6. 6 times -6 is, ding, 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 0. So -1 is a 0. So how do I finish factoring? My original function was x to the 4th power. So what I'm left over with now is 2x to the 3rd power plus 1x squared minus 13x plus 6. The degrees drop down 1. So 3, 2, 1, and then no degree at all. All right, so now I have a cubic that I'm going to factor. I can use numbers off of my list again. So let's take another number off of our list. Does anyone want to try? Let's try a fraction just to see what happens, just to get some practice. All right, so drop your 2. 2 times 1/2 is 1. This is a 1 here. 1 plus 1 is 2. 2 times 1/2 is 1. Negative 13 plus 1 is negative 12. Negative 12 times half is negative 6. 6 plus negative 6, 0. Ding, ding, ding. I have another 0. Now what I'm left behind with, drop your degrees again. So instead of being to the 3rd power, this is now to the 2nd power. To the 1st power, no power. Now this is a quadratic. These are much easier to factor. You don't have to do the guess and check. Notice there's a GCF here of 2. So I'm going to go ahead and factor out 2. And then I'm going to use my standby factoring techniques, looking for 2 numbers that multiply to -6, add to +1. And those 2 numbers are +3 and -2. Okay. So I do have all of my factors at this time. I need to go ahead and collect them. Okay, sorry about that. So I need to collect all of my factors. So this right here, some of my factors. I'm going to see if I can get them up to my list without rewriting them. All right, so these are some of my factors here. And then I also have those other zeros, this -1 and this half. My factors use the opposite sign. So for -1, my factor will be x plus 1. And then for +half, my factor is x minus half. We don't like fractions in our factors, so I'm going to go ahead and multiply everything through by 2. So it's 2x minus 1. I have 4 factors, which should not be a surprise because it was to the 4th degree. So anything to the 4th degree, this is your fundamental theorem of algebra. To the 4th degree has to have 4 roots, also 4 factors. So for my zeros, I'm going to set each of these equal to 0 and solve. These 2 are already done for me. This one right here is -1. This one right here is +half. And then I'm also going to get 2 and -3. X minus 2 equals 0 if x is 2, because 2 minus 2 is 0. And likewise, -3 plus 3 will equal 0. Okay, so these are my x-intercepts. My zeros are my x-intercepts. There's an x-intercept at negative 3, 0, at 2, 0, negative 1, 0, and 1/2, 0. What about my y-intercept? Your y-intercept happens when x is equal to 0. So I'm going to go back and look at my original function, and I'm going to put a 0 in. If I put a 0 in, this term becomes 0. 0 cubed is 0. 0 squared is 0. 7 times 0 is 0. So I'm left with 6. So my y-intercept is 0, 6. So that's all the analysis I can do. The last piece of this is sketching. So in order to sketch this, I'm going to first draw in my x and my y axes, and I'm going to label them. And I need a scale. I'm going to go ahead and count by 1. So 1, 2, 3, 4. I'm just going to mark one of these numbers. 1, 2, 3, 4, 5. That's going to let the reader know that I'm counting by 1. Right, and I'm going to plot my y-intercept and my x-intercept. All right, and then I could find a point in between each of these. I know that this thing is going up on the right and the left, so it's coming from up high, then it's going to go down, it's going to turn, it's going to turn again, and then it's going to go up forever and ever. So there's a possible sketch of this polynomial. It looks something like a curvy W. So that is it. I know it's a lot. We're going to break this up and work on it in pieces in class. So go ahead and draw your line for your summary and bring your notes into class.